Okay, this is lesson 13 for 7th grade, and today we're talking about parts of a whole. Basically, we're talking fractions or percents today, mostly dealing with fractions. And also some simple probability will be thrown in here as well. So, parts of a whole. Okay, problems about parts of a whole have an addition thought pattern. You have one part plus another part, and it gives you the whole. Fairly simple. Sometimes the parts are expressed as fractions or percents. Usually when I think of parts of a whole, right off the bat, my head goes to fractions or percents, just the way I think. So if we look at a very basic example, it says 1/3 of the students attended the game. What fraction of the students did not attend the game? Well, sometimes it helps for us to look at a picture. Although this answer might be obvious, we have to add up to 1, or 100%. So 1/3 went to the game, that means 2/3 did not. 1/3 plus 2/3 gives us our whole, the whole. So the two parts, 1/3 and 2/3, added together gives us 1, which is the whole. Graphically, it looks like this. All students are represented by this circle, and we're talking about thirds. So we know one of the thirds attended the game, the 2/3 of the students did not attend the game. So graphically that's what it looks like. I encourage students to draw it out if they need to. It might take a little bit longer, but if that helps them understand, by all means, that's fine with me. Like I said, sometimes it helps to draw a picture. If we look at an example like this, it says, I'm not going to try to butcher this name. But basically we have a science beaker that is 61% full. What percent of the beaker is empty? Okay, now we're talking percents. So it would look kind of like this. It's over 50%, and that would be the full part, and empties, less than 50%. Well, we've got 61%, and percents are out of 100. So if 61% is full, we will subtract that from 100%. And we should get our answer. So we're going to go borrow here, 0, 9, drop that there, get 9, 9 minus 6, 39. 39% should be empty. Now, just to check our answer, we could do 39 plus 61, and we should get 100% again. That's how we would go about something like that. We call these complementary, basically. 39 and 61 complement each other because they add together to get 100, or 100%. Alright, some simple probability. Probability is the likelihood that a particular event will occur. We express this probability of an event occurring using the numbers from 0 through 1. We do that with fractions, decimals, or percents. Now, we haven't quite gotten into all of it yet, but if we just look at 1/2, let's say, 1/2 is 50%, or as a decimal, 0.5. So we can express that in any of those ways, and we should be able to convert from and to any one of those. Given any one of them, we should be able to figure out the other two. We haven't really dove into that yet, but we will be getting into that. And the students have probably seen that before. Alright, probability of 0, that represents an event that cannot occur or is impossible. A probability of 1 represents an event that is certain to occur. Probability of 1/2, equally likely to occur as to not occur. So basically we have a little chart here. They say equally likely at 1/2, and anything below that's unlikely, anything above it is more likely, and the closer you get to 1 is the more certain you are. Closer to 0, the less certain you would be. Okay. This is how we write basic probability statements. For instance, suppose we have let's look at this first. We have the probability of an event happening equals the number of favorable outcomes over the total number of possible outcomes. So total and what is observed or what we're looking at basically. So we'll do an example here. Suppose we have a bag that contains 4 red marbles and 5 blue marbles. And we want to find out the probability of picking one marble of a specific color from the bag without looking. Okay, first thing we need to do, we need to figure out how many total number of outcomes there could be. We have 4 red marbles and we have 5 blue marbles. So we have 9 total marble. Okay? So whatever we're looking at in this bag is going to be out of 9 marbles. Now we need to specify what we're looking for. Let's see, this one says, how can we use the formula to find the probability of picking each color? Okay, so first let's look at red. So they say the probability of red, or grabbing a red without looking, will be the number of red marbles over the total number of marbles. So we look back up here, we've got 4 red ones. So probability of red would be 4 out of 9. And vice versa, probability of picking red, okay, never mind. Probability of blue then would be, we've got 5 blue marbles out of 9, so 5 out of 9. And if we add 5 out of 9 and 4 out of 9, we get 9 out of 9. So all of our possible outcome probabilities, if we add those together, we should get 1. Alright, so this is basic probability statements and how to calculate basic probability. We'll kind of look at that with this example. Alright, this is a number cube. It has 1 through 6 dots on the faces, so basically a dice. If the number cube is rolled once, what is the probability of each of these outcomes? Alright, letter A says, what is the probability of rolling a 4? Okay, probability of rolling a 4 is, we know total number of outcomes is 6. And how many 4s are there on a dice? Well, we've got 1. So probability of getting a 4 is 1 out of 6. Probability of rolling a number greater than 4. We're still out of 6. So probability greater than 4, or greater than symbol, just to shorten it. Alright, how many numbers are greater than 4? 5 and 6 are greater than 4. That's 2 numbers out of 6. So 2/6, or that reduces to 1 out of 3. So 1/3 chance that will happen. Letter C, rolling a number greater than 6. Well, how many numbers on a dice are there that are greater than 6? There aren't any. So this has a 0% chance, or a 0 probability chance. This one's for that one there. Okay, and rolling a number less than 7. Well, all the numbers on there are less than 7. So this is a 100% chance. We give that a 1. So basically a 6 out of 6 shot. And we know 6 over 6 is 1. Okay? So those are those ones. And we'll look at our next one here. This spinner is divided into 5 equal sectors and is numbered 1 through 5. And the arrow is spun once. Alright, well first, letter A. How many different outcomes are possible? Well, it's only spun once, you can get 1 through 5, so there are 5 possible outcomes. Letter B. What is the probability of spinning a 3? Well, there's only 1 3 on here, and it's out of 5 total, so that would be 1 out of 5. Oh, sorry. It's a little weird. 1 out of 5. Okay. And letter C, what is the probability of not spinning a 3? Well, if we spin a 3, we're at a 1 out of the 5 chance. Not a 3 would be any one of these. That's 4 out of our 5. So we can see that the probability of not spinning a 3 and the probability of spinning a 3, if we add those together, we get our 100%. Okay? So those two complement each other. I'm going to check my time quick. We're doing just fine with time. I think I need to invest in a timer. Okay. And, so yeah, we said here, when the sum of the probabilities of 2 events equals 1, they are called complementary events. Alright? Now, last example here. The spinner at the right is divided into 1/2 and 2/4. What is the probability of the spinner stopping on 3? Okay? This one's a little more tricky. You have a greater chance of getting a 1 when you do a 2 or a 3. So this is, look at this right here. All of this, that takes up 3/4 of our circle. That means chances of getting a 3 has to be 1/4. So your odds of getting a 3, 1 in 4. Your odds of not getting a 3, 3 in 4. So those are complementary events that add up to 1. Okay? So that is our basic probability. And what was the title? Let me check here. Basic probability and, parts of a whole. Yes. That's what we talked about today. And the lesson homework should be out on the homework link tonight. All right, thanks.